5.4 is sum and difference identities. And you'll notice on your worksheet that I give you, I split up the sum and the difference on the top, only because that's the way it is in the book. But I'm going to write it down all as once, and then we're going to learn the song and the pattern. So I'm going to sing the song first, and then so sine, cosine, plus minus cosine, sine. So then cosine. And when I do this minus plus, that's not a mistake. Over 1. Okay, so you'll notice that I've put 2 equations in one. Well, let me get my arrow to do this. Okay, so I did my sine of A plus B and my sine of A minus B together. So the way that this works when I put it together so that you only have to memorize one and memorize one song is that the plus minus for sine A plus B goes with the plus here. The minus goes with the minus. But then on cosine, so on sine, it's the same sign. But on cosine, when I do cosine of A plus B, A and B are going to be 2 angles that you already have on your unit circle, like, for example, 45 degrees and 60 degrees, to find another angle that you don't know. If I want to do A plus B, it's going to be a minus. So the plus goes with the minus goes with the plus. So on cosine, it's opposite signs. So whatever is in here, it's opposite here. On tangent, you'll notice that if there's a plus here, that goes with this plus and that minus. So it's the same on top, opposite on bottom. The minus on this tangent goes with the minus on top and the plus on the bottom. So it's same sign on sine, opposite on cosine, same on the top on tangent, and opposite. So this is how the song goes. And it's not really a song, it's more of a chant. But it will help you memorize it. And it goes like this. It goes sine, cosine, cosine, sine, cosine, cosine, sine, sine, ton, ton, one, ton, ton. So it will help you memorize that again. So I'm going to kind of go through it again. And I'll point to it and sing a little lower. It goes sine, cosine, cosine, sine, cosine, cosine, sine, sine, ton, ton, one, ton, ton. And it will help you memorize it. I know it's silly, but you're going to remember it, and you can ask other students who have done it before. They'll remember it. So that is all my formulas for sum and difference that you need to know. And these also as well need to go on your yellow pages. So let's look at number 1. I want to find cosine of 105 degrees using my sum and difference formulas. So what that means is I want to come up with 2 angles that add up or subtract to be 105. Before we do that, I'm going to kind of over here just do my charts. So you might want to write all your radians and your degrees, your 30, your 45, your 60, and then your coordinates just so that you remember them. Or fill out your unit circle again. Square root of 3 over 3. This is square root of 2 over 2. Square root of 2 over 2. 1. 1/2. Square root of 3 over 2. Square root of 3. And remember, everything is cosine, comma, sine. And then the other one on the outside is tangent. So let's get back to this. So I'm going to think on my unit circle, what 2 numbers could I have that add up to 105? I would try, if you can, to use at least one of them that's in the first quadrant, because then you don't have to worry about whether it's plus or minus. So I'm going to split 105 into 45 and 60. You could have done it 135 minus 30. You could have done anything like that. So now we're going to go through and expand it. You cannot just do cosine. You cannot just do cosine 45 plus cosine 60. You have to expand out the formula. So this is cosine with a plus. So that's cosine, cosine, sine, sine. Because you'll notice that, remember, when it's cosine, if this is a plus, that's a minus. So we're going to make this A, and this b, and we're just going to plug them in. Again, a lot of plug and chug. Cosine 45, cosine 60, sine 45, sine 60. And then we're just going to fill in all of our numbers. Cosine at 45 is square root of 2 over 2. Cosine at 60 is this one right here. So it's a half. Sine at 45, the 45 most people get right. But the other ones they got to remember. And sine at 60 is square root of 3 over 2. That's going to give me square root of 2 over 4. And then this will give me square root of 6 over 4. And since they have the same denominator, you're just going to write it as one fraction. Square root of 2 minus square root of 6 over 4. So when I ask you for an exact answer and not a decimal for 105 degrees, you're going to give me square root of 2 minus square root of 6 over 4. So using your unit circle and your sum and difference formulas, we can find cosine, sine, tangent, secant, cosecant, cotangent values of things other than what is on your unit circle currently. Next, we're going to do sine, this is example 2, of pi over 12. So you have to come up with two things that add up to be pi over 12. So one way to do it was you could convert this to degrees if it's easier to think in degrees. But instead, I'm just going to think of two numbers that add or subtract to be 12, or pi over 12. So I'm going to think of things that are on my unit circle that obviously pi over 12 is not in your unit circle. But you can reduce things like 3 pi over 12, 2 pi over 12, 4 pi over 12. So if I want to get to a 1, that's going to be I could do 3 pi over 12 minus a 2 pi over 12, because that will give me pi over 12. So 3 pi over 12 minus 2 pi over 12 will give me pi over 12. And then I'm just going to reduce these. This is sine of pi over 4 minus pi over 6. And again, try to use the smallest things you can. If they're in the first quadrant, it's easier to work with them. So that's going to be sine, cosine, cosine, sine, with this being a and b. And on sine, if this is a minus, then there's going to be a minus here. And then we're going to fill it out. So sine pi over 4, cosine pi over 6, cosine pi over 4. Just plug in the angles for a and b. And then we're just going to look things up on your unit circle. So sine at pi over 4 is square root of 2 over 2. Cosine of pi over 6 at 30 degrees is square root of 3 over 2. You'll notice they're going to be all the combinations of your square root of 2 over 2, square root of 3 over 2s, and your 1/2. So you're going to have a lot of 4s, 2s, and 6s. Cosine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is a half. And then let's move this up a little. This gives me square root of 6 over 4 minus square root of 2 over 4. And again, just like the last one, I'm going to write it all as 1. Square root of 6 minus square root of 2 over 4. So, oops. Oh, that's fine. And that's the last thing that I need to do on this problem. Okay, problem number 3. I'm just going to give to you because we're going to do a tangent one. I'm probably going to have to do this on a few screens and maybe move them up. So I'm doing tangent of 3 pi over 4 plus pi over 6. So that's A, this is B. So it's going to expand out to tangent. I'll put in the plus and minuses later. Over 1 tangent. And then since this is a plus, there's a plus between it and the numerator, and there's a minus in the denominator. So tangent at 3 pi over 4, remember 3 pi over 4 is over here in the second quadrant. And in the second quadrant, The only thing positive in the second quadrant is your sine, so your tangent is negative. So tangent at 3 pi over 4 is negative 1. And tangent at 30 degrees is square root of 3 over 3. And then these numbers in the numerator should be the same down here, so I'm just going to recopy them. And that gives me negative 1 plus square root of 3 over 3 over 2 negatives make a plus, so it's 1 plus square root of 3 over 3. So you've got a couple things here. You've got fractions within fractions, and you have radicals and denominators. So the first thing we're going to do is get rid of these fractions in the denominator. These two numbers should be the same, so I'm going to multiply the numerator and the denominator by whatever number is in that denominator. So that's going to give me negative 3 plus square root of 3. The whole point is for these 3's right here to cancel out, divided by 3 plus square root of 3. Now you can't just cancel out the square root of 3's. These are two different things. So now we're going to have to rationalize. So you're going to have to multiply by the conjugate. So that's 3 minus square root of 3. You keep these two numbers the same, just change the sign in the middle. 3 minus square root of 3. Let me move. Oh, it might not be letting me move it up. Okay. I'll do as much as I can on this page before I go to the next one. So that's going to give me, if I FOIL it out, negative 9 plus 3 root 3 plus 3 root 3 minus 3. Because you're doing negative 3 times 3, which is negative 9. Negative 3 times negative square root of 3 is positive 3 root 3. 3 square root of 3 times 3 is going to give me another 3 root 3. And square root of 3 times negative square root of 3 gives me negative 3. Then on the bottom, 3 times 3 is 9. And then 3 times negative square root of 3 and positive 3 times positive square root of 3. Those, the outside and the inside will cancel. Then I'm left with square root of 3 times negative square root of 3, which is negative 3. Okay, well, okay, so I'm going to have to rewrite this on the next screen, so you might want to pause it and copy the rest of this down, because I've run out of room and it won't let me move it up. Okay, so on the last screen, we had negative 9 plus 3 root 3 plus 3 root 3 minus 3 over 9 minus 3. And then I'm simplifying, so I'm going to combine my like terms. So that's negative 12 plus 6 root 3 over 6. And I can take a 6 out of each one of these, and I'm left with negative 2 plus square root of 3. And that is my answer for tangent of 3 pi over 4 plus pi over 6.